So exercise 9, right? Then see, exercise 9 is you're talking about amino acids, right? So you need to uh, I think right here. Amino acids can be effectively represented via OOP. OOP is object-oriented program, right? Because its amino acid has a well-defined chemical composition, right? With specific number of atoms of various element types, right? Like carbon, nitrogen, etc. Right? And covalent bond connectivity that adheres to a specific pattern. Right? So for this reason, the product of an amino acid can be unambiguously defined by the smile strings. Okay? Just look like this. The consists of N, C, H, R, C, O, and O. Okay. So R here is the side chains, and the symbol indicate the I and then some enantiomer, something like that. Okay. So and its the chemical structure is also features specific physical chemical property like a molar mass, isoelectric points, optical activity, or specific rotation, something like that. Okay. So in this exercise, you need to create a amino acids class, right? And use it to define any two of 20 standard amino acid in terms of their chemical composition and unique physical properties. Right? So, so to this, to extend this exercise, consider expanding your amino acid class to include additional class members. For example, like the frequency occurrence of the uh, AA type and the method. Right? The method is, for example, like possible of applying post-translational modification. Uh, so to see the utility of this exercise in a broader schema, see the discussion of the from this paper. Yeah. Yeah, you can click that one. It said the process. This one is 88, this is 85, right? Okay. So the 85 will be this guy. I think I already open it here. This one. Yeah, so for the 80, yeah, you need to open this paper, right? 85 and 88. Okay, so 85 will be this one. You can download the, or you can read online, or you can download from here. Okay. Let me read it online. You also give you the code here also. Okay. So this is the exit part is talking about how to define smile string, right? Okay. So you can see here. So it's free journal, so you can download the application. Oh, yeah, maybe you cannot read it online. No. You can download and see. Oh, apparently, I think you have to pay. Yeah. Okay, yeah, you can download it. Yeah. Okay, so maybe I can set this one. Yeah, let me save it here. Yeah, I can put it in there. Yeah, so that is the 55. Okay, you're talking about the object-oriented uh, plastic, and also about the 3D structure. Yeah, I think this one is like another software. Okay, and you want to um, Yeah, so this one is just talking about here. Yeah, so this gives you the example for an atom, right? This is a example for an atom. This is for an a residue. Okay.
Are you a spider? Or are you still on the Journal of Applied?
The journal, journal number 85. Okay. It's about SMCCRA. Right? So the first example is a example of atom, and this is the example for residue, and then this example for chains, right? Okay. So the first example is identify the oxygen atom from the peptide bond of, of this residue. And in the A chain of the first model in the structure available from PDB as this. And suppression of ID would look similar but would specify only at the level of its parent. So for example, like atom within residue and or a change ID within a symmetric unit. Similarly, for the this one, so we have another example here. Right? So we identify C2 atom of residue of this. So this, the whole thing is an atom and able only include this one will be considered as a residue, and then for the chain will be this one. You can see the order. So the highest one is atom, and then go to the residue, right? And then go to the chains. Okay. And yeah, the residue ID is two. Yeah, so there's another. I think this is the problem that another problem that you need to download. But you don't, it's just okay this one. This is only a sample. Mm, yeah, so okay, so go back to the exercise. Okay, I think I give you the example here how the amino acids look, the classes look like that. Okay, okay, sorry. I think yeah, this is 85, right? The one that I show you for. So this is 85. So, you need to click this one to download it. It is 85, okay. And okay, uh, the other one is the other one is The other one is 88, right? So this one here. Okay. Okay. So the other one is 88 is like this one here. So 88, this one. So this SMILE is a chemical language and information system, right? Introduction to methodology and encoding rules. Okay. Uh, yeah, I think you can download from here. So. Yeah, I believe I can download it for free, I think. Or maybe you can get it online. Okay, yeah. Yeah, it looks like you can. Okay, let me find the one that's spring. Yeah, you can use Google. Okay. Yeah, you can use Google. So let's see. I believe I make so yeah, so the name of the chemical compound. Okay, and then this require an ambiguous and reproducible notation for the simple atom to the most complicated structure. All other chemical information for the follow from the molecular chemical. Sounds good. Okay. Yeah, okay, so okay, for this one, yeah, you can read this one here. What is the purpose of smell, right? So yeah, so you can see the chemical notation language basically is designed for computers used by chemists. It is easily possible to chemists yet flexible enough to allow interpretation and generation of chemical notation independent of specific computer system in use. Similar to- yeah, really computer interactive, right? So the simplicity of this user is on the computer. So it's not record the chemical user input. It is based on optical. Machine training, machine development system. This is HANA's physical work. Semua denotation as a graph that is essential. So chemical structure are given in the following section. Specification of measurement subsection and unique smile generation are subject to following pattern, right? So the first one is atom. Atom are represented by their atomic symbol. Right? This is the target use of letter and smile. Is known as green atom is referred individually by atomic symbol enclosed in square bracket.
Are
Right?
you on Anaconda?
No, I'm still in the paper. The paper for what is this like? Paper of let's see. Paper for this one, yeah. 85. Okay. Talking about smile. Um, so okay, so yeah, you need to understand about the atom structure of the based on the smile. Okay, so you need to read this paper here. Uh, so apparently I can download the Google Scholar. Okay, I cannot download using this one, but I can download using the Google Scholar for the 88. So 88 is a paper, the first paper up here. Okay, the 88. So I can use the Google Scholar and in order to read, in order to download and read the paper. Okay. This in the PDF form. Can you see the PDF one? Can you see my PDF one? I'm sorry, PDF file.
No.
Oh,
We still just see the Google Scholar screen.
oh, okay. Yeah. So this is the paper that. Sorry. So this is the paper that from the Google Scholar. Okay. So this is unique smile generation. Okay. So it is start with atom. Atom is represented by their atomic symbols. Right? So the second, so its non-hydrogen atom is specified independently by its atomic symbol enclosed in square bracket. Okay. So the second letter of the two character symbol must be entered in lowercase. Okay. So the element is in the organic substance, right? P, C, and so on, and may be written without brackets if the number of attached hydrogen conform to the lowest normal balance consistent with the explicit bond. Yeah. Atom is aromatic rings are specified by lowercase letter. So the normal carbon is using capital, right? The aromatic carbon is using the small, using the lowercase letter. So this is a variable notation for the atomic symbols. Okay, C N O P S, and element not in the organic subset must be described in the brackets. Okay, for example, like a code, right? Using the square bracket. And what is another example here? And attached hydrogen and formal charges are always specified inside bracket. Okay. So the number of charge hydrogen is shown in the symbol S followed by an optional digit. Right? So similarly, the formal charge is shown by symbol positive or negative followed by optional digit. Right? So if unshift the number of attached hydrogen and condenser is to zero for another inside. So this example, for example, H plus, I mean it is for the proton, right? Or H negative it is like hydrogen anion and so on. So the small program also recognizes construction of the form bracket. And what the bond? Bond is single, can be single, double, triple, and aromatic bonds, and represented by this symbol. So if you want to example, this is a represent of the atoms, right? CS3, CS3. And then for ethylene, it's just using this one. This is for dimethyl ether, and so on. So this is for the molecular hydrogen. So for example, 6 hydroxy 1, 4 hexadienes can be represented by 3 equally valid letters. So this is the structure. Right? So in the smile, we can represent as what is the first one is CS2 is as C, and followed by this one. And then I think this 3 become this one here. Right? And then the last one, this one become this one. Also can you can do it like this. Or you can do like this. Okay. And about the branches is like this. Enclosures in parentheses, right? Example, uh, so for this branches, branches are specified by enclosure in parentheses, right? So this one in the middle is put it in here, okay? And on the left side here, represent by this one, right? And on the right side, represent by this one, okay? So similarly for this one, so the branch is only one C, right? So put it C parentheses, okay? And then on the left side here, CC, right? I think this one is CH. Yeah, yeah, I believe this is CH, right? Not C, not O. And then C here, and then the branch is O, right? And on the other side here O, okay? So this is how to represent branch. Okay, what is next? Branches can be nested or stacked. As shown in 4 3 profile, 4 isopropyl one heptane. Okay. So this is like this, and then this one, and then the blend will be this one, right? And then this one is this one, and how many here? Just like it's blend and trends, right? So you have a like you have C here, and then you have brand under inside the parentheses, right? This brand, and then the C again, this one, and then close parentheses, and then this one is represented as C C C C. Okay. So another structure here we call it cyclic structures. Okay. Uh, so this one can be represented as C C C C C, or you can represent as like C1 here and then C1 here. So you can put C1 here. So and then C, 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 and then C1. Okay. And there's another cyclic structure here. So like you cut it from here and then go this way. Right? Go this way and then go this way. So the one that is good, the one that is A, as you go this way, it gives you CC1, right? And then cosine, and then CC, and then the brand is PR, and then you have C, C, and then C1. Okay. So you can do like this, or you can do like this. Okay. So the P1 will be CC1, and then equal sign, right? And then CC, okay. And you can consider this one as the brand, right? And this is the P. So all of the brand here are inside the parentheses, right? So start from C, 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 C1. Okay. So there are two ways that you can represent what is atom structure. Yeah, so there are many other here. Also, the disconnected structure. Also, the anomaly aromaticity structure, aromatic structure. Okay. Variating the atom in the aromatic ring. Yeah. We like this one. Yeah. Mm. Okay, so yeah, so there are many example here. Okay. Using some okay. So go back to the assignment. So the assignment is you can I think it's from here. Start from here. In this exercise, create an AA class, right? And use it to define any two of 20 standard amino acid in terms of their chemical composition, and unique physical properties. Then to extend this exercise, consider expanding your amino acid class to include additional class member. Right? So frequency occurrence of the type and the method. Yeah, so yeah, so we need to go to the answer, right? The answer for exercise 11 is, sorry, not 11, 9, right? Okay. So should we go down here? uh, additional. I think I put it in. Okay. Let me set the spider. Okay. Yeah, you can download that answer, and then you can upload it to the spider. Okay. Okay, let me see. Yeah, I downloaded it already. Okay. So this is exercise 10, and this is the exercise 9, right? Okay. So for exercise 9, it gives you the, what do you call it? The class amino acid, right? Okay. So I think this one is example for using the regular extraction. So I need to create a new file here, and I need to copy the answer for number 11, right? Sorry, for number 9. Okay. Control C. Oh, okay. Oops. Yeah, control C. Okay. Yeah, I need to change the name, right? So into save as, so I need to save as, I think it's not in here. Yeah, maybe I should put it together in under the JSEP 2021, 2020, right? Okay. Pattern code. Um, oh, okay. Yeah, I should put it here. So let me try it again. File, Shift S. Yeah, apparently it's not in here. Hmm. Yeah, I forgot where I put it. Hmm. Yeah, sorry, I forgot where is it I put it. It should be in the directory, not in the file. Okay, that's it. Okay. So this will be exercise 9, right? Yeah. And I save it here. Okay, so right there. So it already gives you the example here. So the class is the molar mass, and this is the smile. Is the smile is like the the smile string, right? And then there also electric, and then the rotation. Okay. So this is how to build the class of amino acid. So we already have this. What need to what do you need to add? Okay, you can go back to the example. This is the answer, but it's not complete answer. Okay, so you cannot use that one. Okay, so yeah, apparently this one is not the correct. It's not the correct answer for exercise 11. Okay, so I will show you later. So this one I'm looking for it. Yeah, I'm looking for the answer for the object-oriented programming. Okay. exercise. Some here. Okay, so yeah, I try to you need progress to the like the object-oriented programming, right? Okay. Okay, I think we have it over there, right? Okay, so yeah, so there's 16 and 16 and 15 and 16. Okay, so now let me turn the example for 16 open. Now I need to open number 16 here. Yeah, I want to show you how to build this class, okay? Using the one that we have here. I think this example is talking about object and class. Okay, so yeah, so this example 16, right? It's talking about the class of a rational number. Okay, so it's built a class of rational number. Okay, and the necessary arithmetic operation, or you can say the methods, right? Okay, so it is start with the numerator and denominator. Okay, so this will be the object, right? Okay, and if assistant or is instant, okay, if is instant and numerator and rational number. So the argument should be numbers or rational numbers, okay, and will be the value of this rational number will be the numerator and denominator. So the construction was called with the rational number.
Hey, are you gonna post the last like 2-3 Zooms on the
Yes.
on Canvas?
I thought I did, no? No.
After like from one from yesterday?
Okay. So yesterday we're talking about what? Chapter, sorry, exercise 10. Oh,
Yesterday,
yeah.
what time did the Zoom start? Because I was waiting for like 20 minutes.
When?
Yesterday?
I don't know. Somehow I'm waiting also, but no one saw up.
What'd you say?
I'm also waiting yesterday, but no one saw up.
So
No.
I was there the whole time.
Yeah, we were both there because yesterday class was start at 10.
Yeah, I think I start at 10, I think.
And no, because at 10:20 you still weren't there, so we just left.
Oh, really?
Yeah, we emailed you too.
I
Yeah.
left at 2:30, like at 10:30.
I don't know. Somehow I didn't. Yeah, I think
We
I
were
opened.
waiting for you. We emailed you as well.
I see. Yeah, maybe there is a problem with the Zoom. Usually, if you waiting for me in the Zoom, it will give me. I mean, it automatically will send me email that your student waiting in the Zoom, something like that. But I don't know what happened with this today.
We were both waiting.
Yeah, sorry about that. Yeah, actually I'm waiting also. I don't know, somehow I cannot see you. Okay, so yeah, so this is example of the class. Okay, so we need to build your class based on this. Okay, like so this is all of the example. Okay, and this is the example for the simple class. Right? Okay, so and if your class contain a method called next, you can have iter, right? And then just return self. Okay. Uh, yeah, for this one, if you want to this is a sample for new range 0 to 10, and you need to print from 0 to 10, right? And then SR a simple range. Oh, what is different now? It's pretty simple. Huh? Okay. So yeah, you can see there's an example for the DNA. Um, I think I put it here in the canvas. Okay. Let me see here. So I put this example in the canvas.
Is this example to show us how to do chat exercise 9?
Yes. There's a yes. But it's not complete, right? So there's another example that make you that tries to give you to get the complete answer. Okay. Okay. Let me go back to the canvas. So the example that I show you is already put it in canvas. Okay. Let me show
Yes,
you.
sir. It's already in Canvas.
Oh, you have it. So this is the answer. Okay. And also you can see it under the module right here. So this number. Okay. So this number. I'm sorry, not number. Example for chapter 15, right? And so this is simple class. Okay. So if you type a simple class number, that is because you yellow classes, right? And if you put, if you call use simple class, I think it will give you so this like the call you so not class, no, not class. I think this one is like the definition of the function, right? Okay, so print none. So so this one will be x. The input will be x, y, and z, and the output will be this one. So in the format of XAM. So then, yeah, so this is the hardest part, but this is the important part also, okay, for the pattern programming, which is using the class. Okay. So yeah, so there's another class here. It's like how to gather and settle for some attribute here. So first you get a self. So so you return self A, so return this one here. And set. So that means you need to so from self get the new value. Okay. So you need to set it and then you get it here. And for the this one is just return hello classes. Okay, so so this is the number. I mean, chapter 15, right? Yeah, just another example for the class. Okay, I think the next one is really the important one. You can see there's a how to build DNA and RNA. Okay, so so chapter 16, I think this one is the water temple for exercise number 9. I think you don't have problem with exercise 10, right?
I have a question about exercise 10.
Okay, let me continue this one first again. So this is another example for classes object. You build the amino acids class, right? So this the one that they show you is not complete yet. Okay, so the one that they show you in the answer here, this is not complete. So you complete it. I think you see you before in the bottom of this. Okay. What is this here? Yeah. So this is class DNA store, right? And what else here? Yeah, you need to put together all of this information and, and that as your let's the answer for the exercise. Okay. Okay, let's get biochemical again. Consider class that store DNA. Okay, what's the other one? Yeah, so mm, so what is the missing? Maybe the important thing is we need to understand what is the missing part of the example here. Maybe maybe I need to copy the answer the question. Sorry. Um, Let me set the Python again. Okay. Mm, yeah. Okay. Yeah. So this is actually chapter 6. Chapter 16. Sorry. How to like yeah. So you create the NA store class, right? And then you call the NA store class to another from another class. Okay. And then iterate DNA. I think this one is under this class. Okay. Yeah, I think this one is under this one. Okay, so uh, yeah, what is the one that is missing here? We need to go back to Yeah, maybe I need to put this question also in the code. Okay, you can see what we need to do back. So let me put this question also in the code. Already put it in. Okay. Oh no, I'm looking for exercise 9, right? Sorry, not this one. Exercise 9 should be this one, right? So let me put the question up here. Okay. Yeah, so okay, so you start from here, right? In this exercise, create an amino acid class, right? And then you should to define any two of the 20 standard amino acid, okay, in terms of their chemical composition and unique physical properties. Okay. Uh, so what is the okay, so you need to put the chemical composition. So the chemical composition is what is it? Like I think the in small, right? So the the chemical composition will be in this object. Okay. And what else I need to put? Unique physical properties. Okay. So the physical properties here. Okay, we did that one, right? Then the chemical structure, physical, physical-chemical properties. Okay, so this one of them is a molar mass, right? What else? Isoelectric point, isoelectric here, okay, and then optical rotation, right? Okay. So we did like I think we did for yeah, I think we did for this one, right? And then need to continue with the next one, yeah. To extend this exercise, consider expanding your AA class to include additional class member. Okay. So in this case is frequency occurrence of AA type and the method, the possibility of applying post-transitional modification. Okay. So that means you need to uh, yeah, one you build the amino acid and then you need to find like how many frequency, what is the frequency occurrence and that amino acid, right? Okay. So you can see, maybe you can go back to, yeah, maybe you can continue with exercise 10 as well, right? In exercise 10, you can find what is the frequency of the residue, right? Or the atoms. Okay. And yeah, so you need to add two more class member, yeah, which is class member and also method, right? Class member and instances frequency, and then the method can be post transitional modification. Okay. So I think you can go back to the exercise plan. So Taylor, you're asking about exercise 10, right?
Yes, sir.
Okay.
I was just confused on how to upload the file, the FASTA file.
Oh, okay. Yeah, so to upload that file, let's see here.
The file.
Yeah, I will say here. So you need to go to the, yeah, you can follow through. Okay. So you need to go to the canvas here. Yeah, so you need to click this one here. Okay. Download the PDF file and pasta from this
Okay.
website. Okay. So you need to click this one here. So you can here download the file from the link below under the download file tab by choosing PDB, for example, and or FASTA type for the exercise 10. Right?
Mhm.
So for the exercise 10, you need to click this one here, and you go to the website. Right? You can see on the right side the download file, right?
Yes, sir.
So you need to click that one, and then click the pasta sequence. So you click the pasta sequence, and then save it in your pattern codes. Okay. Yeah, I already put it here. See,
Mhm.
under the Python code. So already put it here. I mean, already you download it. Okay. So once you download it there, now you need to use the spider to to call it. Right? Okay, let me see. Uh, okay, yeah, I try exercise 11. I think this is not the answer. Okay. So I need to validate not the answer. Let me see. Okay, let me call the Python code and the file. Okay. So it should be exercise. Oh, no, it's not exercise. No. Yeah, surprisingly, I cannot see exercise online. Yeah. Yeah, so this is you can copy and paste it from. So it's just simply adding the one line here down here. So we'll
Can
solve
you
the
write
problem.
it right quick so I can
Yes.
see what it's supposed to look like?
This one.
Yes, can you run it?
Yeah. So I just for this one, for from here to here, just copy from the answer. Okay.
Yeah, I copied everything and I put like and
Yeah.
I
And then you
saved
put
file.
and then you put a pro line followers. That means calling the function.
Yes, it's just not working.
Yeah. So you need to call the function and then put the name of the file, the pasta file.
Yes, but it says no such file or directory. File not found.
Yeah, you need to make sure you put the file the same, and also make sure like the letter is not has to be exactly the same, right? If this is one here is if this one here is the uppercase letter, and the file also you have to be uppercase letter. Okay, let me call the file. Okay, so you can see this is the file is I put it here, pasta. Oh, okay. I think I need to put like all file. Okay, so in order to see it, you need to pick all files. Okay, now you can see it. Right? So the code for exercise 10 is here, right? And the pasta file also has to be in the same directory. You can see here the pasta file is right here. So it's the same in the same directory under the Python code. Okay. And make sure the name is the same. So if it's a capital letter, you have to use uppercase letter, you have to use uppercase letter. Right? So in this case it's uppercase letter. So you can using I, capital I, and then 8, and then capital I, and then dot pasta. Right? Yeah, let me call this. Okay, so this the pasta file look like this. You can see also it's the same as, or similar as the one in example, right? The example is not exactly this one, but just example, using the greater than a sign. Okay. So once you put the code and the input file in the same directory, and also you need to name the output file. So in this case, I put the name of the output file as output proline.txt. Okay. Let me run it now, okay, so you can see it, what happened. Okay, so I already run it, but the output is not in the console, but the output is in this file. Okay, so you need to looking for this file. Open and looking for that file. Okay, this is the file here. So you can see here. Can you see the file or not? Let me set the window. Oh, it's not here. It's not this one. No. Oops. can you see my window?
Yes, sir.
Yeah, so this is the output here. Can you see it?
Yes, sir.
So you can see the output is, hang on. So this is the input file, the pasta file, right? And you can see the output file is this one here. So you can see this is new file. You can see this
Mm-hmm.
get modified 526, which is today, right? And then the time is like 2:20, 2:38 p.m. So like 3 minutes ago. Right? So this is the output that it just ran. Okay. So let me call this. Let me open this file. You can see what is inside there. Yeah. So this is the output file. So this is the content of the output file. Right? Remember the output file is the first column is what?
Okay.
The first column here is this one is yeah, this one here. Output track. So as you can see, the first column is the residue, right? And then the second column is all percent. And then the third column is the proline percent. And everything is explained here. So yeah, so everything is explained here. Okay?